Okay, so in lesson 6, we are looking at the quotient rule. We just looked at the product rule, and now we're going to look at the quotient rule. Obviously, this is division. So if you take a look at this guy here, I've basically got one function divided by another function, so g over h. Now, our formula, or the quotient rule here, is I need to take my denominator times by the derivative of my numerator minus my numerator times the derivative of my denominator, it's like a tongue twister, divided by my denominator squared. Crazy. So again, remember with that product rule that we did before, we brought in u and v just to make it look a little bit easier, a little bit nicer. So let's do that again. So if I have f of x is equal to u over v, what our derivative of that is, using our quotient rule, is I'm taking my my denominator times the derivative of my numerator minus my numerator times the derivative of my denominator, all divided by my denominator squared. Okay, so let's put this into action in a couple of examples here. So number 1a, you can see obviously we've got a fraction here. This is my u and my v. So remember, and this, don't forget, don't panic, this is all on your formula sheet. I've got vu prime minus uv prime over v squared. What we're going to do now is go ahead and find our derivative. So v is our denominator. So I've got 3x squared times the derivative of my numerator. So guys, 1 is going to turn into 0. X is going to turn into 1. 0 plus 1 is 1. Minus u times the derivative of my denominator, which is going to become 6x. All divided by v squared, which is just literally 3x squared squared. So it's going to just become 9x to the power of 4. All right, so that's the main step. If you don't get that one, the rest of it's obviously going to be wrong. So you just want to make sure you do that carefully and properly. And now all it is expressing this in a simplified way. So 3x squared times 1 is just going to be 3x squared. Minus, now be careful with your brackets, guys, and careful with that minus sign. I always get students making that mistake. So if you want to be really careful, just draw your bracket and then expand. So 1 times 6x is 6x. X times 6x is going to be 6x squared. Some of you will probably do that a lot faster without the brackets, but it just depends on your comfort level. Now we can obviously expand this a little bit more, get rid of those brackets. So 3x squared minus 6x squared over 9x to the power of 4. Now we can go ahead and simplify even further. So 3x squared minus 6x squared is going to be negative 3x squared minus 6x, all divided by 9x to the power of 4. Now, also what we can look at is simplifying our numbers and simplifying our variables, right? So I can divide everything by 3, and I can also divide everything by x, and basically we can just kind of simplify that and cancel it all out. So I've got prime, so if I divide everything by a 3, and then x, this is just going to become negative x minus 2, all divided by 3x cubed. Again, what I do to the top, I do to the bottom, I'm good to go. So I'm dividing by 3 and I'm dividing by x. And then one last step, just don't forget, sometimes we don't like having a negative in our first term there, and sometimes we just like to factor it out. So that's going to be x plus 2, and then we would have 3x cubed. And then that would be our final answer. All right, so let's try another one here. I've got my one over on the other side, B. I'm just going to erase all of this. And we're going to do the same thing, and then I'm actually going to show you guys something cool that you may not have noticed yet. All right. So here's my u, here's my v. Obviously, we've got the quotient rule situation because we've got a fraction there. So I'm going to take remember my formula. So f prime is going to be VU prime minus UV prime all divided by V squared. So my V is 2x plus 4 times the derivative of my numerator, which is going to be 10x, minus my numerator times the derivative of my denominator, which is just going to be 2, all divided by 2x plus 4 squared. Now simplify, kind of like repeating the steps over and over again. So expand and simplify. So we've got 2x times 10x, 20x squared, then we were going to have plus 40x. And then again, be very careful, please, please, with that sign. Okay, draw your bracket if you need to. 5x squared, so that's going to be 10x squared minus 2, all divided by 2x plus 4 squared. Now keep going. I'm going to have 20x squared plus 40x minus 10x squared plus 2, all divided by 2x plus 4 squared. And to finish off our numerator here, we've got 20x squared minus 10x squared is just going to be 10x squared. So these guys are gone. I have plus 40x and then plus 2. And that can be divided by 2x plus 4 squared. Now there's variations of how to come up with your final answer here. What we can do is go ahead and simplify all of our basic, sorry guys, you could go ahead and evaluate and expand this denominator. You could do that, or what you can do is just leave it as is. So it's going to depend on your question. So you could either do, just take a look at your multiple choice and see which one is going to properly match your answer a little bit better. Now, that's one version of your answer and one version of how to get your answer. But another way, guys, and again, like I said, you could simplify, you can, manipulate that however. I think you guys are probably at the stage where you're getting good at that and match it to your answer. But an important note that I really want to draw your attention to here is that we can actually make a quotient rule into a product rule. So if you look here, up at these questions, I'll just erase this, get it out of the way. So if I look at this, this is actually the same as 5x squared minus 1, and then I could times that by 2x plus 4 to the power of negative 1. So it says, important note, all quotient rule derivatives can also be done as a product rule if you move the denominator up to be multiplied by the numerator. To do this, you must change the sign of the exponent on the denominator. So this would be an example of how to change it. And right now at this stage, we're not equipped to find this derivative just yet. But this is a note that I'm going to kind of come back to because we're going to learn something in a little bit called the chain rule, which is actually going to allow us to use the product rule and the chain rule together rather than the quotient rule. So you'll be able to choose what method you want to use. All right, so for C, we're going to keep going here. I've got my crazy looking guy here. So we've got our U and our V. Remember that we want to always switch this so that I don't have any radicals. So it's just going to be 2 over 3 and 2x to the power of a half. And again, that's going to be my U and my V. We absolutely could simplify this first. We could take our numerator and divide it by our denominator and go ahead that way. And it's going to be quite a bit quicker than using the quotient rule. However, painfully, I want to practice the quotient rule with you guys. So we're going to do that one instead. So we've got, remember, our VU prime minus UV prime all over V squared. So our V is going to be 2x to the power of a half times the derivative of my numerator. So that's going to be 2 over 3 x. And then I need to minus 1. So that's going to be to the power of negative a third minus my numerator times my denominator, which is just going to be, the derivative of my denominator. A half times 2 is 1, so it would be x, and then minus 1 would just be, again, negative a half. All divided by 4x, because don't forget we're squaring our denominator there. Now come fraction craziness, which you guys will need to become comfortable with. So we're going to multiply everything together, first of all. So I've got 2 times 2 over 3, so that's going to be 4 over 3x, and I'm adding my exponents. So I've got to kind of make these guys out of 6. So this one would be like 3 over 6, and this one would be 2 out of 6. And so 3 out of 6 minus 2 over 6 is going to give us 1 over 6. Minus, and again, I'm multiplying these guys together, so I'm adding 2 over 3 plus negative a half. So again, that's going to be like out of 6, so that's going to be 4 out of 6. And this one's out of 6, so that would be negative 3 out of 6. So again, we're going to get 1 over 6, all divided by 4x. Now we can simplify our numerator because you'll see that they're common terms. So 4 over 3 minus 1 is going to leave us with 1 over 3, x to the power of 1 over 6 over 4x. Now, a fraction and a fraction, yuck. So remember, if I've got a denominator in my numerator, sounds kind of crazy, this can automatically just go to the bottom. So this actually becomes 1 over 12. And we can simplify as well these guys here. This is like 1, or we could even say 6 over 6. So we know that we would have 5 over 6 left over in our denominator. Okay? And if I wanted to write that as a radical, it would be 12 and then the 6th root of x to the power of 5. Okay? So that would be our final answer there. So this is a little bit tricky, again, when we throw in all of these fractions. So just be careful that you're practicing. All right, now the last question for this lesson is finding the derivative of this function using the product and the quotient rule. So this one we have to do a combination of everything that we've learned so far. Now, first thing hopefully you're seeing is that we could actually use our, simplifying method here. So this times this would become that minus x to the power 4 over 4x cubed. And guys, you want to be smart when you're doing these, like if you can simplify something beforehand, you definitely want to try and do that. Again, if we've got our u and our v here, again, you could divide everything by x cubed. It's x over 4. And that, that's one way of doing it. And then we could use our quotient rule. So lots of different ways that we can do these. So let's do that. I've got my y prime is equal to vu prime minus uv prime all over v squared. So my v is 4 times u is going to be 2x squared minus x. Oops, sorry, I'm taking the derivative of that. I'm just rewriting it. So that would be 4x minus 1 minus u, which is 2x squared minus x, times v, which is going to be 0, because the derivative of 4 is 0. And then divided by v squared is just going to give us 16. All right, so now let's multiply through. So I'm going to have my 16x minus 4 minus 0, right? Because all of this is going to be 0. So we can even just like get rid of that minus sign, and then that's going to be divided by 16. So this is cool, right? We always love when we're taking the derivative of a constant. And now we can simplify. So remember, what I do to the top, I do to the bottom. So we can take a look at dividing everything by 4. So that's going to be 4x minus 1 all divided by 4. Okay, so that would be our final answer there. So again, I just kind of want to go back up and say, like, there's many ways of doing this question. You could, again, simplify like what we did, and it's also saying using the product rule. So what you could do, and I'm not going to go through this with you, but you absolutely could turn this into, you know how we simplified the top here? So we did 2x to the power of 5 minus x to the power of 4. If I wanted to use the product rule, I would just multiply by the, basically reciprocal of what we see there. So it'd be 1 over 4 x to the power of negative 3. And then you could use the product rule with your u and your v. So just another method on doing the same thing, and if you're doing it right, you absolutely should get the same answer. So at the very bottom, as always, sound like a broken record, practice, practice, practice. This stuff is not easy. It's brand new, so really practice.